We are going to be solving the Cameroon GC Advanced Level Computer Science 0795. Today we are solving June 2023 Paper 3 Database. Before we start, I want you to know what are the core objectives of this particular tutorial. By the end of this video, you should be able to 1. Understand database scenario, design an entity relationship diagram, write an SQL query accurately in Microsoft Access, insert and retrieve data accurately, avoid common exam mistakes, and solve these plus other GCA practical questions. Well, let's look at the instructions first. Use this lesson to verify your approach, not to memorize answers. Pause the video whenever necessary to think or attempt a step yourself. Pay attention to the reasoning behind each solution, not just the final result. Multiple choice questions will appear during the lesson to check your understanding. Write down your answers and key observations as the lesson progresses. Submit your responses and questions clearly in the comment section after watching. Attempt full paper independently before watching this video. Very important, so that you are going to actually check out your understanding, as I'm going to be solving completely and we will not have time for detailed explanations. But if you attempt the entire paper yourself, you will have more insights and use the comment section better. Alright, so we're going to dive in directly to task 1, but one thing I always tell my students is to always read the entire question paper immediately as they want to start the exam. Alright, this is the paper, June 2022, Computer Science Paper 3, Cameroon GC Advanced Level. The paper is 2 hours, and if you allocate the time well, you are supposed to dedicate an hour for database or less, and all the remaining time to Task 2, which is programming. Task 1 is all about database for a furniture company. It's 24 marks, right? 24 marks. The company sells furniture to customers of its store. The store does not keep furniture in stock. Instead, a customer places an order at the store, and the company then orders the furniture required from the supplier. When the ordered furniture arrives at the store, a member of staff telephones or emails the customer to inform him or her that it is ready for collection. Customers often order more than one type of furniture on the same order. For example, sofa and 2 chairs. Details of furniture, customer, and orders are to be stored in a relational database using the following relations. So you have relation furniture, furniture ID, furniture name, category, price, supply name, customer order, order ID, customer ID date, customer order line, order ID, furniture ID, quantity, customer ID, customer name, email address, telephone number. The attributes for these relations and orders used eventually are detailed as follows. Well, you have the description, the data type, the field size, and the remark. Furniture ID number, field size 6, remark must be present, and so on for all other attributes of the various relations. You are to develop a database for the furniture company via a subtask given below. Roman 1. In your answer booklet, give an entity relationship diagram that shows the degree of the 3 relationships that exist between the above entities. Remarks. Roman 2. Using SQL statements, do the following using your favorite database management system. Well, you just keep on reading the entire question to the end. I think it will take you maximum 10 minutes. We're in the 2 hours, or if you are a fast reader, 5 minutes, you can read the entire paper as fast as you can. Alright, I'm going to be reading back the questions before starting the solving. So without wasting so much time, we are starting directly with Roman 1. So we are going to actually go to our answer booklet and give an entity relationship diagram that shows the degree of any 3 relationships that exist between the above entities. 3 marks. So we have the relations and we have everything. Good. Now let's look at the relations that were given to us. The database relations are furniture, customer order line, customer, and you can see the various entities. These are the entities, these are the attributes, and you can see the primary key being on the line, which is the main identifier of all records in this particular table. Let's look at how the relations appear. We are first representing the various entities in these rectangular boxes to just see how they allocate. Now we want to see the relationship between them, because we were told at the beginning that it is a relational database. That means it's a relationship between customer order, customer order line, and furniture. Well, to see that, simple. You have to look for any entity that has a foreign key of another one. Like here, you can see furniture ID is the primary key of furniture. There is no foreign key here, meaning there is no primary key of another table. Customer order ID is the primary key, but here we see customer ID, which is a primary key of customer, which tells us directly that there is a relationship between the customer table and the customer order table. When we come to the customer order line, we see order ID, which is the primary key of customer order, furniture ID, which is the primary key of furniture. This shows that there is a link between the customer order line and the furniture table, and a link between the customer order line and the customer table, and customer does not have any foreign key. This gives us the first link, which is the one with the order ID, customer order line, and customer order, and the second link, which is a relationship between the customer order line and the furniture. Once you have identified how the relationship is linked amongst the different entities in our database, the next thing to do is to draw our entity relationship diagram. We start by putting our entities in rectangular boxes and the name inside. Well, then you put your attributes in ovals for the various entities, making sure that you have underlined the primary keys accordingly and written the various attributes in the ovals. Next, you have to actually link them up as identified earlier with diamonds in the middle. That is going to give us the relationship name that exists, the relationship that exists between the linked entities. You can see here the relationship that exists between customer and customer order is places, meaning a customer places an order. The relationship that exists between customer order line and customer is contained, and a relationship that exists between furniture and customer order line is appears in. Well, you have to understand that there is no specific relationship or a constant relationship that everyone should have, or a specific name. You just need to look for an action word, a verb, or like a descriptive word that actually can be placed to read from here to here. Customer places an order, or you can say customer orders an order. So there's no specific name. Any name can go as far as it can be read from here to here and from here to here. Well, now how do we read? We read through cardinalities. Cardinalities tells us what is like the degree between a customer and the customer's orders to the furniture. Well, we are going to look at that using this relationship mapping points, which is, you can see here we have 1, and here we have m for many. You can still put infinity. Let's just put for all the other relationships. 1 to m means one customer can place many orders. One order can be found in can be contained, yeah, because you can see I read with the relationship name that was there. That many alternatives relationship names, and any one that makes sense and it actually makes the relationship readable and valid is good. So that's how I read this, and same thing here. One furniture can be found in many customer order, can appear, yeah, in many customer order line. Okay, now before we continue to the next question, I told you that you're going to have 5 questions that will appear on your screen. You are looking at an entity relationship diagram for a database. Which of the following sets of matches correctly identifies the standard chain notation symbols? Entity equals to oval, attribute rectangle, relationship diamond. B, entity is a rectangle, attributes an oval, relationship is a diamond. C, entity the diamond, attribute the rectangle, relationship line. And D, entity rectangle, attribute the line, relationship and oval. Pause this video. Think you have maximum a minute to answer this question. In your answer booklet or on your paper answer sheet, just store the answer to question 1 and we continue. Good. Now that we have answered Roman 1, we have 3 marks already. We finished drawing our AR diagram. If I'm too fast, pause the video, read, and go at your pace. Roman 2, using SQL statements, do the following using your favorite database management system. 1. Create a database called cells. In cells, create all the relations given above. You can see that Roman 2 is specific on using SQL statements, meaning you have to write SQL statements for both 1 and 2 because they are both under Roman 2. In total, 5 marks. So let's go to our answer booklet and write directly how to create a database called cells. So you can see here my Microsoft Access is open already, but there is no appropriate method to actually come and insert an SQL query here to create a database called cells. This is the database management system called Microsoft Access, and it doesn't permit that. So instead create a database, you need to pass through the GUI, and here I will just type cells and click create. Good. But in your answer booklet, you were told to use SQL. So you are going to write create database cells semicolon. This is the SQL query to create databases. In other DBMS like XAMPP, you can actually do this, create a database through an SQL query. Next, we are told to create the relations given above. meaning all the tables, the entities, the attributes, and the relationship that exists between them in a table called cells. So to do that, first I would like to show you how the SQL could look like before we can type directly. You can see here the furniture table. We have create table furniture, furniture ID int primary key, furniture name text 15 because we want to make sure that we align with this table. That is why I told you to read the entire paper. You will know that the field size of every attribute is given and the remark should be null or not, like present or not present. You see the remark here, and the data type also given. You can see here is number, varchar, meaning text. Okay, so we have that. That means we know exactly how our attributes should look like. Alright, so let's create the furniture table directly. I'm going to come to create. I'll go to query design here. I don't need this yet. I'll just change my view to SQL view. We are going to use the SQL query design and the SQL view to create the first table. Let's start with the furniture table. Yeah, it's the first table. We start with the furniture table. So the SQL query is simple. We write create table, then we write furniture, and inside our brackets, we put the various attributes. The first attribute is the furniture ID joint, which is an integer and is our primary key. Then comma, the next attribute is the furniture name. It is a text, so I will just say text, or you can say varchar, varchr. So text size 15. Must it be present? Let me check that. Furniture. Okay, I'm checking furniture name. Okay, there's nothing here, so we don't need to put no. Good. Next, we have category, which is a text. Field size 615, and this one actually is not null, meaning it must be present. Next, we have price, which is currency, and not null too. Well, you can put all of this in capital, like text, right? Currency, you can put them in capital, but I think it's not that case sensitive, so I can use this. So supplier name, text 10. Good. So I don't need to put a comma again because it's the last attribute. It's like I was listing items inside this bracket. So I put my bracket and I close with a semicolon. That's the syntax for SQL in MS Access. So now that I've written the SQL query for the furniture table, what I need to do is to run. Furniture table has been created. So in a similar manner, we're going to create all the other tables. Well, since the customer table looks alike, we are going to use the same queries, and you're going to see it's not going to be that hard. Yeah. So let's create the customer table in a similar way. I'm just going to say create table, customer. It's always good to review your work after typing because you can have a typo like mistake and you can't change it later, or it's going to waste your time. So make sure that you always check your work twice before even clicking on the run button. So we have this, and we know that it's our primary key. The customer ID takes 6 primary key, customer name takes 15, comma, we go to email. The email is a text 20. Next, the phone number, an integer, that's it. Okay, I just have to review all of this. Customer name, text, email. Customer ID is there, customer name is 15, email 20, telephone number integer. But integers don't have field size, so like here there's a mistake. You don't put a size in an int, okay? So you run this, because if you do that you have an error. So now let's create the next one. This one is a little bit tricky because we are creating the relationships directly, and we realize that the customer order table and the customer order both have foreign keys. So we need to reference them to their specific tables. As you can see here, customer table, you have to put create table, customer order ID int primary key, customer ID text 6. Yeah, references, because this is a foreign key in the customer table. References, customer ID, you are linking them directly. Order date time, because you are creating the relationships at once. And the customer order line table, the same thing. You can pause this video and check what you did. Good. Alright, so I'll do this very quick. Create table, customer order. This is the table I want to create now. Now we have order ID int our primary key. Next we have customer ID, which is a text of size 6. Okay, we put the references, customer table, customer ID, reference to this, comma. Next we have the order date, and I put this, I close with a semicolon, I run to create a table. Good, customer order created. Next table. Well, I don't need to remove everything. I'm just going to put line here. Good. And I replace these ones in the middle. The first one is the order ID int. Well, it's not more the primary key, so I'm going to remove this. I'm going to state it as customer references. Okay. References, customer order table. It has to actually match up to the order ID. Then comma. Then we have the furniture ID. Okay, I think you should just remove all of this. And in furniture ID, it's an int references. I'm going to reference the furniture table, referencing the furniture item. Well, when you have a table with two keys like composite, there is another way to declare the primary keys here that we're going to look at immediately. You have to come here and type primary key, then in brackets put the two primary keys that are there. We have the order ID as the first primary key and the furniture as the others, both of them from the primary key here in this scenario. So we run this and we can see our tables created. Well, you just have to copy these queries in your. I have to close this without saving because I don't need the queries anymore. All I needed was to create the relationships and everything. So if I close the table 1, it's going to disappear. Now I just open all my tables to check. Customer table, yes, ID is there, everything is there. Customer name, email, telephone number. Okay, customer order, because if I committed an error, I just have to change to the design view and modify my query. No need to run it back. Well, furniture ID, furniture name, category, price, supplier name, everything is good. All tables were created. Now let's check if the relationship was well created. We come to database tools, relationships. You can see relationships created because we created the tables referencing to others. So you can see cardinalities and everything exactly as you created. You can see the primary keys was stated, the attributes. This is a relational model of representing the entire database. Good. So we close this. Yeah, definitely. I did not even change anything. We are done with Roman 2, 8 marks already. This is like, yeah, beautiful. Roman 3 says, populate the relations in your database with 5 to 7 rows of furniture data and 3 to 4 rows of customer data. The data entered for customer order and customer order line should be consistent with those for relations, furniture, and customer. That is, their data should derive from the furniture purchase transaction that the customer made. 8 marks. Well, I think here we are open to put any information. Yeah, like there's no particular table that the GC bot gives, so you can put all information except your information. Don't forget this is an exam and you don't have to dispose or maybe give out your details that can lead to sanctions if you read the instructions at the beginning of your paper. Before we start populating, here comes your question 2. When creating the furniture table, why did we add not now to the category and price fields but not to the supplier name? A. Because supplier names are too long for the database. B. Because the business can sell an item without the price. C. Because the instructions mark category and price as must be present, making them mandatory. D. Because supplier name is a primary key. Pause the video, answer, and just wait till question 5, then submit question 1 to 5 through the comment section below. Okay, we go to Roman 3, which is the population of the various tables. So I'm not going to use SQL to populate this because when you're using MS Access to populate in SQL, every record, meaning a single line, every record is a single query. And that's going to take us a lot of time if you want to put one query for one record, one query for. But you can use this time to copy this in your answer booklet because the instructions says clearly. Yeah, here you must not use SQL, like it's not stated. The SQL was just for Roman 2. To populate, you can populate manually, like you just come here, open the table and insert the values. Well, if you want to do using SQL, this is a SQL query to populate. These are the information we're going to put, and this is how we're going to fill in our table. And later, it's going to look like this. The furniture ID table will be like this, furniture name will be like this, category will be like this, price will be like this, supplier name like this. Now you can see our furniture ID. They're just various numbers that I put, and I put this 10765 because I saw down here we are asked to write an SQL query that will delete, like we are just supposing that by mistake you had this number, like it's just random. Okay, you can put any ID like 001, 002. There's no convention, you can just do that as you want. Furniture name, you can see I have office chair, dining table, sofa, bed. You can see category, I have office, this is the price, I have them all, and supplier name as well. Same thing for my customer table. Here is the query, here is the table, and this is how it's going to look like at the end. customer table, these are the values. Now you can see that the order ID and input here must be found in the customer order table. Yes, like any C here, because we have to make sure that we respect data integrity. Every value here should be found there, and same thing here. Furniture ID, you shouldn't put an ID that does not exist, or an order that does not exist, and a quantity, because we want to make sure that an order, someone ordered a particular furniture and a particular quantity, meaning if I want to see this, I should know who placed this order just thanks to this order ID, and I should know the quantity and what was the particular furniture. That's why it is highlighted here that the data should be derived from the furniture purchase transactions that the customer makes. So that said, I will go a little bit fast to populate my various tables with the data you have seen in all these queries. Okay, so let's go. I will start with the furniture table. Alright, now that we have populated all the tables correctly, customer, furniture, customer order line with informations that we choose, here I'll advise you not to have long names, long stuffs, just short. Don't actually waste time typing, because you need to economize and make sure that you're quick to use your available time for other sections of the question paper, because if you waste time populating, you might not have time to complete the question paper. Now, before we continue, I think you have a look here on how all the tables look like. Good. Now let's go to the next question theorem. Throughout this assignment, we use constraints like not null, primary key, and references. Which of the following best defines the concept of data integrity? Ensuring that the database runs as fast as possible, protecting the database from being hacked by external users, ensuring the accuracy, completeness, and consistency of data throughout its entire life cycle, making sure the database has a large enough storage capacity. Next, Roman 4 says, okay, for this subtask, this is a note. First, write in your answer booklet the SQL queries or statements used to implement activities in your database management system. Suppose a fault has been identified with the product whose furniture ID is 10765. In order to contact all those who purchase this item of furniture, the manager of the company needs a list of their names and telephone numbers only. Also, the list should be placed in alphabetical order of customer names. Names and telephone numbers only, and the list should be in alphabetical order of customer names. Give an SQL query that produces these 2 marks. That's an SQL query to delete from the database the faulty product with furniture ID number 10765. Okay, 2 marks. So C is also asking for SQL query, same as D. Alright, so let's do that quick. To do that, you are going to actually either use SQL directly in your SQL command create and SQL query design. You need to add all the tables because we need to see them and the relationship between the tables, just as I did. I had to select and click OK to add it here in this visual space as you've seen. And you can see different views here. You can change to SQL view. You can see just like remove this, type whatever query you want to type, and here you actually see there are many views. Okay, let me add back the tables. I deleted them, sorry. The SQL query was there for well, when you're here to add the tables, you just click here. Yeah, this appears back, and I select them all and add, close. Good. Now I need to know exactly what I need to get the furniture with ID 10795. Now we are told that a fault has been identified with product whose furniture ID is 10765. Okay, so let's first look at the first method to do this. The first method to do this is to go to the SQL view as I said and just type the SQL query. Select this thing, customer name, customer table from this. So you do inner join to join the various tables that we are going to use. We're going to use the customer table. Yeah, and from the customer table, we're going to need the customer ID, we're going to need the order ID, because it is the order ID that tells us that someone purchased a particular furniture. Because once you purchase, you get an order ID. And now the customer ID is who purchased it, because we need the name of the person and the telephone number, where customer ID, because this is here like customer name and customer telephone number, where customer order line dot furniture ID is equal to 1065, order by customer name ASC, meaning arrange in ascending order. So you can type that here in the SQL view. But here I want to use the easiest method, which is the one I recommend to every student to use. And this method is quite very sharp and quick, and we don't really need to waste time. And you copy the SQL query that comes after, because retaining all of this is quite complex and a lot of students find it so hard and difficult. So the method I'm talking about is using this panel. To use this panel, I just have to double click on the various attributes I'm going to use. I'm going to need the order ID, but here you can see show. I will remove show because I don't need show. I'm going to need the customer name and telephone number. Yes, these two are going to be showed. Well, I'm going to order in ascending order of customer names here. What else do I need? I need to identify this particular furniture ID. So a faulty product has been identified. So let me look for furniture ID. I need 107. It comes to here criteria. I will just put equal to 10765. Good. Now that we have this, we have to know all those who purchase this. I think we are good with everything here, customer ID, order date, and order ID. Okay, let's run the query first and see what comes out. So you can see here we have two people, Alice Smith and Bob Jones. This is their telephone numbers. This is furniture ID. But now we were told that we don't need to show out furniture ID, so we remove this. We click on show, but we leave this criteria because we need this particular ID for the criteria we choose for furniture ID. Don't forget. But now this furniture should not be coming from the furniture table. Yeah, because we are not sure that this has been purchased already. We are going to take this from the customer order line table, this particular furniture ID. Because this, if any furniture ID is found here, it is sure 100% that someone ordered it. We don't even need this section at all, so I'm just going to delete it. We maintain this table. So not very well from what table you take your attributes, because we said that all furnitures are here. Obviously they have their IDs, but nothing assures us that it has been ordered already. But the instructions tells us that the product was ordered. Suppose a file has been identified, product was furniture ID, in order to contact all those who purchased this item. Those who purchase are definitely under the customer order line. So I can track from the ID of the furniture, and from there we can see what order was it. So once you do this, you run, you can see them here, customer name and telephone number. Alice Bob Johnson, this person. You can just come and check here. This is customer order. We have this particular order, so this is order ID. Like if you want to link it normally, it's so long, and yeah, it's going to take us a lot of time. This is the first one, office chair. Like, well, it's going to take a lot of time to identify like that. That's why the query helps us to actually view it quickly like this. And as you can see, it is in ascending order of customer name. Well, we are going to now go to the next part, which is to copy the SQL query. Now how it works, you see it's quite long. Yeah, so you have to copy this quick in your answer booklet. It has been generated. So if you wanted to go otherwise, you have to copy all of this, or a short version, which is this. So just copy this quick. If you don't know this, if you can't master it. Alright, now let's continue. Alright, so B says write an SQL query to delete from the database the faulty product with furniture ID number 10765. Okay, so to do that, you just need to type the SQL query, select, as you can see here, delete from furniture where furniture ID equals 10765. No quoting it because it's an integer. So we write it here directly. Delete from furniture where furniture ID equal 10765. I run the code directly. We're here, query design run. We are told that yeah, we're about to delete one row from the specified table. When we click yes, we say Microsoft can't delete the one record because there are key violations whatsoever. That's true, because actually we can't delete this because it is linked to another table. You can see this furniture table is linked to order ID, the customer order line table, as you can see. So when you have already populated, you can't actually delete. So let's just give a try to another query, another site. Like here you can see this one is not linked to any other table. So we can actually come here and delete this particular one. Just try on your side there. So that's the SQL query. We're not told to like do that. This is it. I just copied that in my answer booklet and I continue. That's it. 2 marks. Alright, C. Alter the table customer order to include a field called validation. The field holds a short explanatory text for faults found in an order, or the word known if there is no fault. Well, before we do this, we are going to have question 4, which says which SQL clause is used to combine rows from 2 or more tables based on a related field. A. Join. B. A group by. C. Where. And D. Order by. Pause to reflect 1 minute maximum. Once you have answered the 5 questions, get to the comment section and submit. Alright, okay, we are about to alter the table customer order and we're going to include a field called validation. And we have a sort of explanatory text called known if there is no fault. Beautiful. So to do this using SQL, we first know that the table is customer order, so we need to add a table called validation here. To do that simple, we are going to say order table customer order, add column validation varchar because it's a text, okay, default none. This default none does not work in a DBMS MS Access. Yeah, it works on XAMPP and not in Access. So we're going to use this section only to actually add the table validation, and we're going to go to the design field before adding none for the default field. But in your answer booklet, copy this entirely. So let's go to the query alter table customer order. Yeah, we're altering the customer table, the table customer order. And we're going to add a column called validation. Yes, varchar or text, anyone. Let's try default first and see what happens, or the error we are prompted. Since it is a string, I'm going to put a string directly. None in capital letters. Yes, it was placed bolded. I need to like pay attention to bolded words. Semicolon. While I run this, syntax error in alter table statement. None. Access does not know this actually. So I run this. The database engine could not lock the table. Okay, when you see the error message lock, you have to close the particular table you want to work with after saving it, of course. So let me just close all the tables before I execute the query. Well, after that, I have to execute this query. So I click on run. No error message, that means something happened. I open back customer order. You can see the field called validation added properly. But now when there is nothing, none is supposed to appear, like it is written there clearly. The word none if there is no fault. Good. Meaning we are going to come to the design view here and edit ourselves. So we need to come to the table validation here, and in the default value here we put in double quotes none as it is written in the question paper, double quotes as you can see here, but we want just none to come out. Mindful of how you produce the list of names and telephone numbers in 4A above. State in words how one will remove a faulty product from your database. So we know that in 4A we were creating a relational database. Once these dependencies are removed, we are going to delete the product from the furniture table and ensure the data consistency and prevent orphan records. So if you understood the linkages, you can't delete a particular records in a table when that record is being used in another table. So you make sure that you first delete from that other table the child one before coming to delete in parent and others. If you want this particular file, the database all solved with all the information, the population and everything, and the answer guide to the 5 questions asked, go to the link in the description below and download it. See you in the next video where we'll be solving the section B, which is a programming. Remember to do it yourself before watching the video. Ciao Bella!